Number 12 says the dimensions of the rectangle shown below are given in inches. And before we go any farther with this problem, I just want to point out that this is something that the ACT does a lot of times. They'll just give you extra information that's not helpful at all. Like if you look at the answers, none of these have anything to do with inches squared, right? Like here it says which of the following expressions gives the area in square inches of the rectangle, and that's not necessary. So we can just ignore all that. Really, this question is just telling us to find the area of the rectangle. So finding the area of a rectangle just means width times height. So I'll take 2x plus 1 and multiply it by x plus 2. And I like to use the box to multiply these together, and it just helps me organize my work. So I'll write it under the second factor there, the x plus 2, and then write 2x plus 1 over here. Multiply that all together into the box. So 2x times x gives me 2x squared. 2x times 2 would be 4x. X times 1 is x, and 1 times 2 is 2. And then we have to combine our like terms here. So the first box gives us a 2x squared, and then we have a 4x and an x that have to go together, so that would be plus 5x, and then the 2. All right, so that's the area of the rectangle. We don't know the actual value for it, but that's the expression, and that matches up with k. Number 13 says the polynomial 45x squared plus 26x minus 8 is equivalent to the product of 5x plus 4 and which of the following binomials. So there's a lot of vocab going on in this problem. The first one is polynomial, which is just kind of the bigger family function name that quadratics belong to. And then the other one is binomial, right? Binomial just means two terms. This is a binomial, and then all of these are binomials. So polynomial just means, like, if bi means two, then poly means many, right? So it just means many terms or multiple terms. And we have three terms here. You could also call it a trinomial, but anyways, that's kind of besides the point. This question is really asking us to take this and factor it into 5x plus 4 and something else. So I'll work through that way first and then show you another way you could approach this problem. If we were going to factor this, I like to use the box method for factoring just because it gives me a process that I can follow. So we draw a box. We have to also draw an x off to the side. On the top of the x, we do a times c. So that would be 45 times negative 8, which is negative 360. And then the b value goes on bottom, so 26. And then you ask yourself what multiplies to negative 360 and adds to 26. And the first numbers that come to mind are 36 and 10. I just got to figure out which one should be negative, right? And I want them to add to 26. So if I did 36 plus negative 10, that would make 26. And 36 times negative 10 gives me negative 360. So that works out. Okay, so now we can fill out our box. Okay, so the first term, the 45x squared, goes in the first box. The negative 8 goes in the last box. And then we weren't sure how to take this 26 and split it between these two boxes, but now we know. We're going to put 36x up here and negative 10x down here. So then you just have to start factoring out of the box. So if we look at the first column, if we look at what these have in common, well, between 45 and negative 10, the biggest thing, the greatest common factor, the biggest thing I can pull out of both of those would be 5. 5 goes into 45 and 10. And then they both also have an x in common. Okay, so now you can start figuring out what to put over here. All right, so like what times 5x gives me 45x squared? Well, I know I for sure need an x here because I need to make an x squared. And then 5 times 9 gives me 45. All right, and then 5 times what gives me negative 10? Well, that would be negative 2. And we have this x here, that x ends up there. So that's all good. And then 9x times what gives me 36x? Well, 9 times 4 is 36. And then you can just check your work in the last box. Is 4 times negative 2 negative 8? Yes, it is. All right, so we successfully factored this into 5x plus 4. That's the one they gave us. And 9x minus 2. So your final answer would be B. But here's another way you could approach the problem that's actually maybe a little bit quicker. So if we're taking 5x plus 4 and multiplying it by some binomial that we're trying to figure out, and we need that to multiply to this quadratic, think about just like foiling this out. If you were to foil it, which is another form of like the box method of multiplying, FOIL just means first, outside, inside, last, right? First, outside, inside, last. So 5x times something, and that has to give us our x squared term. So you could kind of just figure out automatically like 5 times what gives you 45? Well, that would be 9, and of course we need another x. And then if you think about the last step, you'd have to multiply 4 times something else, and that's going to be your constant, and that's going to give you negative 8. Right? So 4 times what is negative 8? Well, that would just be negative 2. And just like that, we figured out the same answer that we did before. All right, this number 13 says, what is the sum of the two solutions of the equation x squared plus x minus 30 equals 0? So here's a quadratic that we have to solve. And the first thing I want to try for this problem is factoring. If I see a problem that looks kind of simple like this, I always want to try factoring first because if that works, it's usually pretty easy. Okay, and you might be able to just guess and check this, but I'm just going to go with the box method again. So a times c on top would be negative 30, b on bottom would be 1. What multiplies to negative 30 and adds to 1? Well, that would be 6 and negative 5. So then you can put the first term in the first box, last term in the last box, and then put 6x and negative 5x in these corners. All right, so between x squared and 5x, or negative 5x, they just both have an x in common. No numbers can be pulled out really, just because we just have x squared. And then x times what is x squared? That would be x. X times what is negative 5x? That would be negative 5. And then x times what is 6x? That would be 6. And then 6 times negative 5 is negative 30. So that worked out. But we're not done yet. We have x plus 6 is one of our factors, and x minus 5 is the other factor. And remember, if this is set equal to 0, I can just solve them separately. So x plus 6 equals 0, just splitting these up, and x minus 5 equals 0. So this solution would be negative 6, and this solution would be 5. So here's another trick that the ACT will pull, because after you've done a math problem, sometimes you're a little bit stressed out, and you're like, okay, cool, negative 6 and 5, got it. And then you look at the answers, and you're like, wait, negative 6 and 5 are both answers, and then you start to get frustrated. But remember the question said, what is the sum of the two solutions? So we have to take these two numbers and add them together. Sum means add. So negative 6 plus 5 is actually negative 1. Number 28 says, which of the following most precisely describes the roots of the equation 5x squared plus 7x plus 2 equals 0? And we're given all these choices here. So one, rational double root. Well, rational just means like fraction. It could be written as a fraction. Double just means that it would be a repeated solution. So you'd have the same solution twice. Irrational numbers are things that include like square roots. So if our final answer has a square root in it that can't be simplified, that would be irrational. And then the last one here says complex, and that would just be with imaginary solutions, right? And this says non-zero imaginary parts, because a complex number is like a plus bi. It has a real part and it has an imaginary part. And we can't, and it says with non-zero imaginary parts. That just means that we have to have a complex number that actually has an imaginary piece to it. It can't be just 0i. So with all that said, that just means that we have this quadratic that we have to solve and then figure out what type of solutions we have. Now I'm going to use the quadratic formula because that has the discriminant, and that actually tells us something about the solutions. So I'd normally try to factor it first, but in this case I'm going to try quadratic formula, which is the opposite of b, so negative 7 plus or minus, and then b squared, which I'm actually going to do in my head. 7 squared is 49, and then it's minus 4ac. So a is 5, and c was 2. All of that over 2a, and again a was 5. So now I just have to simplify this. Okay, so we've got negative 7 plus or minus, and now here's the discriminant. If I simplify the stuff in the square root, that's going to tell me what types of solutions I have. So negative 4 times 5 would be negative 20, times 2 would be negative 40. So 49 minus 40 would be 9. So I've got the square root of 9 all over, and then this would be 10. All right, now the square root of 9 can be simplified. So I know I'm not going to have an irrational number. I know it's just going to be a nice number because the square root of 9 is 3. And then I can do like negative 7 plus 3, negative 7 minus 3, etc. So it's not going to be irrational. It's not going to be irrational. And I know it's not going to be complex because I can take the square root of 9. It doesn't give me any imaginary numbers or anything. So now I've just got to figure out, is this going to be one repeated solution? Am I going to get the same thing twice? Or am I going to get two different rational solutions? Well, it should make sense that we're going to get different solutions, right? Because if you take negative 7 plus 3 over 10, remember the square root of 9 is 3, and then if you take negative 7 minus 3 over 10, you're going to get different answers here. These are not the same thing, right? So those are our two solutions, and they're different, so our answer is H, two rational roots. And I probably should have said this right away at the start, but a root is just another word for like a solution. And sometimes they'll use the word zero instead, so they'll say find the zeros of this equation, or find the roots, or find the solutions. Those all mean the same thing. Number 28 says, which of the expressions below is a factor of the polynomial 2x cubed plus x squared minus 6x? So I included this problem because it kind of relies on factoring, which is something we talk about when we talk about quadratics. But I will say that this polynomial, like I said, is actually a cubic, right? It's to the third degree. But it's asking us to factor it, and if you look at these three terms, they each have an x in it, right? So I could factor an x out of all of those three terms, right? It's kind of like reverse distributive property. So if I wrote an x out front and then thought about like what would be left inside, If I take an x out of this first term, that would give me 2x squared. If I take an x out of this term, that would give me just a plus x. And then I could factor an x out of this term, and that would just give me minus 6. So at first, okay, we see that x is a factor, and then x is one of our options, so that's looking good. And at first you might be tempted to just say the answer is f. But you have to be patient because the other things might also be factors. So I wonder if I can take 2x squared plus x minus 6 and factor it farther, especially into one or both of those things. So I'll work through the box method for factoring and put a times c on top, which was negative 12, and then b on bottom, which is 1. And then things that multiply to negative 12 and add to 1 would be like 4 and negative 3. So now I can put 2x squared here, negative 6 there, and then 4x and negative 3x. All right, factoring out of the box here, we've got just a 1 in common, right, between 2 and negative 3. Nothing else is really in common, but they do both have an x. And then here between the 4 and the negative 6, I could pull a 2 out of both of those. In the top row, these both have a 2 in common and an x. And then in the bottom row, I could divide both of those by negative 3. And then you should probably just check, is negative 3 times 2 negative 6? Yes, that worked out. And like negative 3 times x, yep, that all worked out there too. Okay, so here's our two factors, x plus 2 and 2x minus 3, which is actually so close to these other options that they gave us, but they don't actually match up. So it really is only 1, so f. Number 29 says, which of the following expressions is a factor of the polynomial x squared minus x minus 72? So again, we're going to factor this, and I'm going to speed the process up because you've seen the box method a few times. You're welcome to keep trying that. If you want to use guess and check on this, it's a pretty simple quadratic to factor. We're really looking for like what times what would give us x squared, which would obviously have to be x times x. And then we're looking for two numbers that would end up multiplying to give negative 72 and adding to be negative 1, which would be negative 9 and positive 8. All right, so then looking through our list of factors here, this one's really close, right? But it doesn't actually match up with b, so our answer is just a, x minus 9. Number 32 technically has to do with quadratics, but in practice it involves a little bit more like reasoning and problem solving than anything about quadratics. So it says, when a store sets the price of birdseed at $3.50 per pound, the store sells 2,500 pounds of birdseed per week. With each 25-cent increase in the $3.50 price per pound, the store sells 100 pounds less of birdseed per week. Let n be the number of 25-cent increases in the price per pound. Which of the following expressions represents the dollar amount of the store's weekly sales of birdseed? So honestly, this problem is a mouthful, but it comes down to this last question. Which of the following expressions best represents the dollar amount of the store's weekly sales? So just put yourself in the position of like working at the store. If you're selling birdseed, think about like what that would look like mathematically. If we're looking for like the total weekly sales, like the dollar amount, like how much money they're making, you would figure that out by taking the price of the birdseed and multiplying that by like how much birdseed is bought or sold. Like if they start at $3.50, you would take that $3.50 price times however many pounds are sold. For instance, 2,500 pounds. But this just tells us one specific instance, like for one price and for one amount of pounds. This problem's a little bit more complicated than that because they're saying that the price is going to change by 25 cents, and that's going to change also how many pounds are sold. So we just have to make this price look a little bit more complicated. Well, it's going to start with the $3.50, and then they said that they're increasing the price by 25 cents, so plus 0.25, and then here they said let n be the number of increases. So we want to take that increase amount, the 25 cents, and multiply it by n. So here's our starting price, and then this is kind of like the rate of change. And then we have to do the same thing for the number of pounds sold. It's a little bit more complicated than just this one single number. We do start with 2,500 pounds. That's the starting amount they give us. They said when a store sets the price at this per pound, they sell this much money, or they sell that many pounds. Okay, but as we change the price, the number of pounds also change. How do they change? It says the store sells 100 pounds less of birdseed. So I'm going to subtract 100, and that happens for every increase in n, or every time n changes, that the number of pounds changes by 100 as well. And so that matches up with letter K. Number 45 says, which of the following is an equation of a parabola that passes through the 3 points labeled in the standard xy coordinate plane below? So we just want the equation of a parabola, or a quadratic, right, that would pass through these 3 points. So it would have to be upside down like that, which clues you in right away to knowing that the a value has to be a negative number. So looking at our options, well, here a is positive and here a is positive, so it can't be either of those. But actually another thing, just looking at the options, not even thinking about the rest of this problem, it did ask for a parabola, which means that it has to have basically like an x squared in it somewhere. Well, these are all kind of written in intercept form, but like if you look at a, we've got two factors, each with an x. If you were to multiply those together, that would create an x squared. In letter b, we have this factor being squared and then times another x. So this one actually has two x's and then another one. This is actually a third degree polynomial, so that's not even a parabola. That would be like a cubic. This isn't a parabola either because it has another factor being squared. This has another factor being squared. So none of these make any sense. We're just choosing between a and e, and we said it can't be e because the a value there is positive, right? We want our parabola to go upside down. We need the a value to be negative, so the answer would have to be a. Number 55 is another problem that has to do with sales. Here it says a sporting goods store sells baseball caps for $22 each. At this price, 40 caps are sold per week. For every $1 decrease in price, the store will sell 4 more caps per week. The store will adjust the price to maximize the revenue. Okay, we want the maximum revenue. What will be the maximum possible revenue for 1 week? So first let's see if this note is helpful at all. It says, note, the revenue equals the number of caps sold times the price per cap. All right, so number of caps, well, let's see, it says we start out at 40 caps per week. So let's start out by putting a 40 here. But I think that changes, right? Because as we decrease the price by 1, it says the store will sell 4 more caps per week. So I'm going to say 40 plus 4, and then I guess we'll use n, kind of like we did in the last problem, but n is like the number of weeks. So we have the number of caps, and then it says sold times price per cap. All right, so the price starts out at $22 each, so I'm going to put a 22 here, but then that's changing by $1. It's decreasing, so I'm going to subtract 1n. All right, now this just gives us the quadratic. What we're actually looking for is the maximum. So let's see what would happen if I were to multiply these two together. We'll draw a box under this factor, and then write 40 plus 4n here, and multiply everything together. So 40 times 22 would be 880. 40 times negative 1n would be negative 40n. 4 times 22 is 88n. And then 4 times negative 1 is negative 4. And then we have n squared. All right, so writing that out in standard form would be negative 4n squared. If I put these two together, that would be 48n, so plus 48n. And then our constant at the end is just plus 880. Now let's pause for just a second and think about what this would look like graphically. I'm not sure exactly where this is going to be on a graph, but I know it's going to be an upside down parabola. So I'm just going to draw something kind of like this. And if we're looking for the maximum, we want the maximum possible revenue, and that was like the output of this function, was the money that they were going to make. So that's like the y value. So on the graph, that maximum that I'm looking for is really the vertex of the parabola. Now to find the vertex of something in standard form, we would do the opposite of b over 2a. So in this case, that would be the opposite of 48, negative 48, over 2 times a, which was negative 4. All right, 2 times negative 4 is negative 8. So if we have negative 48 over negative 8, that would be 6. Now that's not our answer. If you look at the options here, 6 definitely isn't an option. 6 is actually the x value. We just found the x value for the vertex. But if I want the maximum revenue, remember that's like the y value for the vertex. So then I just have to take that 6 and plug it back into this expression to see what the output would be. So negative 4 times 6 squared plus 48 times 6 plus 880. And at this point, you just need to type this into your calculator. So I just did that on Desmos, and I got 1024, which would be E.